to 4. So 5 classes are there where 0 is a no DR. Okay, these are the industry benchmark and popular data sets available. And one more data set is also available called as IDIT data set. Okay, and then as you can see, these are some samples that I have presented. These are called fundus images, which is taken by an ophthalmologist using for the using the patient's, let's say, uh, retina, and then we can see that no DR, mild DR, and these are keep on degrading. So these are all the blood vessels that are actually rupturing and the bleeding is occurring, and then based on the non-treatment. If the treatment is done at the earlier stages, then we can, of course, uh, prevent the severe and the proliferative DR. Okay, and then so these are some of the data sets that we use in our work as well, and 4 data sets have been used. And then in any medical data set or even in general machine learning problems, we always see that there is a imbalance in the data. So in mostly in the medical data set, the problem is that class 0, because lots of people, okay, out of the, let's say if you screen 100 patients, maybe 90 of them doesn't have a DR because maybe they are not diabetic, and then the remaining 10 has all these 1, 2, 3, 4 classes. So because of that, we always suffer or have the problem of imbalanced data set, especially in medical data set, where the if you want to detect cancer in lungs using the, let's say, X-ray images or something like that. So if you take 100 X-ray images, maybe 90 or 80 is having no such symptoms, where the remaining 10 or 20 may have. So this is a skewed data set that we always see. So we have to, in any, not only in this data set or in this task, if we have to remember that handling such imbalanced data set problems is a job of a machine learning engineer to solve. Okay, so coming to coming to the title, where we have said we will be using transformer for our computer vision models instead of CNN. So CNN is the convolutional neural network, which is a very famous model which has been used for quite a long time in the AI domain for computer vision tasks. And how do you use this transformer? Transformer is a model which was introduced in 2016 only, and it is the model for language. Okay, so how can a model that is being used for language be transformed into images? Okay, so there are certain ideas after the introduction, and its effectiveness has been proven in the language domain. And as we know, all the AI, large language models, generative AI that we use today are all based on transformer. These LLMs are all transformer models, pre-trained transformer models. And then by using this transform, how can we transform this into a vision model? And which always use the something called self-attention mechanism for enhancing its performance through a self-supervised learning process and so on. So in that case, certain ideas. Okay, first idea is why don't we add attention in the CNN existing CNN model? This is a sample CNN architecture known as a residual network, where the residual connections or direct connections are given in between the layers, as you can see here. Okay, and so why don't we add some certain self-attention layers in this, right? There is one possibility, and then maybe it will. We hope that it will increase the performance, but this is still a CNN, and we don't use the full potential of a transformer network. So in that case, we will take the idea of our language. In language, what happened is that if I say, for example, this sentence only, this question. So this is one token, another token, third token, fourth token. There are so many tokens, and even these are tokens. And then in transformer model, we will take this as single token, and then put that into our transformer model for some sort of classification, generation, and everything. And image-wise, how can you divide this? That is the problem. So first intuition is use the pixel level. Okay, you use one pixel as one token, another pixel as another token, and keep on going until, okay, feed the image as a set of pixel tokens, and then feed that into the standard transformer that we already have, and it has already been tried, as I mentioned earlier, in this reference, and then we can see that if it works or not. Now, as you can see, the problem here is, in case of language,
Hello, sir. You are not audible.
our internet got disconnected. Sorry for the disturbance. I hope we are visible and audible. Where was the disconnection? In which part? Yeah. So I was talking about how to make the improvement in the standard transformer by standard CNN by using a transformer approach. And then the first idea was simply adding self-retention mechanism, and which is not a good idea because it's still a CNN. And in the second case, we take the intuition from the language where we use each token as the input to the transformer. And instead of taking, we don't have a token in system in our image, so we will take the pixel value. So one pixel, second pixel, third pixel, like this. So that one we can do as shown here. The pixel-based tokens are given as a feed to the transformer model, and then the transformer can process this, hopefully, and already tried in 2020 XCML. Now the problem here is, as I mentioned earlier, if you take a SD image, if you take a sentence or a paragraph or a document, maybe 1000 or 2000 words max, at max. So that can be processed by our transformer. But if you take a HD image, how many pixels will be there? 1080 into 780 pixels. So how many pixels are there? How many tokens it has to process? So that is the problem. So the memory use is going to be a problem. And then how much of memory? So a simple 128 by 128 image is going to take 768 GB of memory, and which is not a feasible approach. So what can be done? So we'll simply divide this, right, into patches. We'll take this as one token, another token, third token, like that. So this is the building block, right? Okay. So first token, second token, third token, up to so many tokens. So in that manner, we can avoid this problem of a overhead where we will be taking so much of inputs unnecessarily. And we'll take the same idea from the original transformer where, since you can see that this has been broken up, we don't know the order, it has become a maze or a puzzle. So we have to know that, okay, which image. So this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So we have to give that a position encoding as well. So we will encode it into vector and add the position encoding. To add the position encoding for each, like in the language transformer, and then finally we will find a, vector, a combined vector, which is representing each section of the image. And then we'll simply feed that into a standard exact same as your NLP transformer, language transformer. And finally, we can classify uh, using the final output, which is a simple dimension. It's a simple vector, which will be used for classification or any other purpose. So this is the third idea, and which is going to work, and it is nothing but your vision transform, the VIT. Okay, so computer vision, so with no convolution, although there is convolution inside in form of MLP and other things, but yeah, it is a vision transformer. Okay, and then yeah, so these MLPs are there inside. If you dive deeper into deeper into the transformer, you'll be getting all these MLPs and fully connected networks and so on. So those are all your convolutions, one by one convolution. Okay, so these are the memory that is going to be that are usually taken uh, in VIT, and it is quite efficient even compared to our CNN models in terms of utilization of the, let's say, memory in the GPUs and so on. Yeah, so if you take a 224 by 224 image, you will be getting uh, for 8 heads 112 MB and 16 heads 192 MB and so on. Okay, now that is what vision transformer is, and then uh, let me see what is that. Okay, there was a comparison. I can't remember. Okay. So vision transformer can outperform CNN in certain tasks, and it is quite good. However, the problem in vision transformer or VIT is that, as you can see here, these patches are divided into these kind of uh, token kind of uh, patches, and then these patches, in case of transformer, if you study okay in the future, or maybe if you know already, in transformer there is no uh, encoding type of a process where, okay, so suppose in a CNN, what happens is that if you start with the 224 by 224 image, it is getting, the features are getting extracted, and at every level the features are compressed, meaning that here it may be 64 by 64, and here it may be 28 by 28. So it is reducing. Okay, that means that we are actually trying to uh, uh, extract the information which is only useful for our task. But in transformer, it is parallel in nature. Okay, it goes like whatever comes in, it goes out. So that is a problem. Okay, that works for a language transformer where we don't need all the compression. It needs to know the meaning of the words and comparison between the neighboring words and the relationship between the words, attention between the words, and so on. But in case of our vision transformer, which doesn't have these features, doesn't decrease the resolution and increase the number of channels when you go deeper into the character. So this is useful, as is already mentioned here, useful for images at various scales. For example, there are maybe multiple images in the image, multiple objects in the image in case of object detection, or maybe the image has multiple scales. For example, one big apple image, one small apple image, and these kind of decreasing resolution, increasing number of channels is quite important in case of computer vision. So that is being followed in CNN. That's why it's so popular. But in case of VIT, we are not following that. You can see first block, second block, third block, everything is same. In case of CNN, your stages are going to be okay. Initially, you started 56 by 56. Finally, you are ending with 14 by 14 uh, resolution. So that compression is actually needed, and this is a hierarchical model which CNN uses, and then it is quite useful as we mentioned earlier. And in case of VIT, that is not a case. Although it is quite efficient in terms of parallel computation, uh, all the in let's say the matrices can be in case of keys and queries and values. Okay, all these can be computed. All the uh, floating point operations can be done inside the GPU efficiently, but it is the isotropic architecture where remains the same. The channels remain the same. The pixels remain the same. So there is a problem. If you see, for increasing the efficiency, increasing the accuracy of this. So for that purpose, we will go into a hierarchical VIT model, a recent model, which we will be using in our diabetic retinopathy uh, detection task or grading task as well, which is known as a swing transformer. Swing transformer is a hierarchical approach to the VIT. Okay, so whenever you have the channels, uh, you want to keep on increasing the channels where you are decreasing the, for example, this is a channel, right? Okay, you want to decrease this resolution and increase the channel. Okay, so that is not being achieved in our transformer block, you can see here. So in case of hierarchical, we want to achieve that by increasing the channels and decreasing the resolution. Okay, you keep on merging the neighborhood patches, and then initially you'll have 4 by 4 patch, and then later on you merge the neighboring patches and make it 2 by 2 and so on. So keep on going that. So you can see, it becomes or behaves like a CNN now. So initially you have these many patches. Later on you have increased the number of channels like in CNN, and then we decrease the number of patches resolution. And finally, you can do a linear projection to uh, compute, okay, to make it to a manageable level of channel, and so on. And then you keep on, if you keep on increasing in this manner, it becomes very much like a CNN model, and then it also efficiently extracts the, let's say, extract the features accordingly, and then we can do the final processing of any grading task, detection task, even a generation task can be done at the later stages. So this is a swing transformer. Swing transformer actually stands for shifting window transformer, which we'll see. So how we will achieve this is another concern. It is not shown here, but I'll show you shortly here. Okay, yeah. So another problem is that the attention matrices, the QKV, we have QKV or keys and queries and values, all these matrices, these are attention matrices which needs to be computed. And if you have these kind of structure, it is going to exponentially increase. Okay, for that purpose, we'll be using a local attention mechanism where will the attention will go over only the local patches, not on the all the patches. So the swing transformer. So as this is the introduction, addresses the scalability and efficiency issues of your BIC by introducing the hierarchy like in CNN and the window-based approach. Okay, like again like CNN. In CNN also we have a sliding window approach where we slide our filter over all the patches of the image. Similarly, that is being transformed into our transformer network. And in a hierarchical approach, okay, we'll start the images in layers and then grow into smaller patches and so on. And then we will use a shifted window attention. The shifted window attention meaning that, okay, uh, to overcome this, we cannot have the attention for all the patches. If you have this many entries needs to be maintained and it's not feasible. Again, the same problem comes with the original transformer model. So we'll be using a attention mechanism that shifts through only the certain local windows, and then later we'll merge it. Okay, so initially the problem was quadratic. Okay, where if you have this many tokens, yeah, the 224 by 224 image, and each attention matrix will be this much of size. So initially we started with, okay, one window like this. This is the one full image, and then these are the 4 patches, and then instead of taking the attention in each full attention on all entire image, we'll take, let's say, divide into m is equal to 4 window, 4 by 4 window, is 4 by 4 window, right? And then we will compute the attention on only in this, okay, the kind of local attention. In that case, we will try to reduce the attention mechanism. So uses m is equal to 7. Swing uses m is equal to 7 throughout the network. Okay, now the problem is that if you are computing your attention only this, then the model is going to see only this part. If the apple is not present here, how is it going to detect the apple in that patch, right? Or if there is a half, or even in case of a diabetic retinopathy, if the blood vessels are here and some are here, if we are not going to see an overall picture, then how is going to see? No communication among all these windows, right? That is required. That is required for efficient increasing the accuracy of our model. So for that purpose, we'll be using the shifted window attention. That is the name of the swing transform, shifted window, SWIN, shifted window attention. So the alternate between the normal windows is the shift windows, like in your CNN. So you shift, shift like that. Okay, one image I have shown earlier. Yeah. So this is the exact representation of the difference between the swing transformer and the VIT. So initially swing transformer VIT sees the same image over and over again, same number of patches, because the dimensions are not reducing, resolution is not reducing, the channels are not increasing. In case of twin transformer, initially we will start with like this, and then later on we will merge the neighborhood, right? And then again we'll merge the neighborhood. So this is what a hierarchical approach. This is a hierarchy is level 1, level 2, 2 and 3, right? Here no level, all the same. Going through again and again, right? So there is the approach that shifted swing transformer is going to follow, and then we shift the windows, right? So in case of swing transformer, we are not going to use the position encoding, which is the very standard approach in transformer model in case of NLP also, where we use position encoding because we need to know the position of each window. But in case of swing transformer, instead of using position encoding, we'll be using some sort of a thing known as a relative position. Okay, what is the relative position of your window, right? Because you're going to shift. So I am relatively okay next to one of the windows and further to another window, right? So that's why our standard attention value will change. So this is a standard mechanism that is being used in the NLP. Your ChatGPT also uses this one, right? The softmax attention mechanism, the softmax of QK transpose into V, right? Where V is the value, Q is the coding, and the K is the key, right? Normalized by the dimension. Okay, so this cannot be used anymore because we don't have the position encoding, right? Instead, we are using some sort of a relative position. So the relative position, okay, needs to be learned. Okay, so we'll learn all the biases of the positioning of the because of the shifting of the window. So the formula changes finally to capture the relative bias. Okay. Yeah, so that is these are the things that I wanted to talk about regarding vision transformer, why we are using VIT and modification of VIT, that is swing transformer, instead of our standard CNN approaches, which will be seen here. Okay, here we have the swing transformer, the yellow one, the orange VIT, and the red net. Okay, red net and the efficient net is here. You can see this is on the imaginary data set. So when we compare the performance of our swing transformer compared to vision transformer, as well as regular CNN models like uh, uh, efficient net and other CNN models, we can see that okay, the transformer model, which is the swing transformer, overcomes the accuracy versus speed. This is the speed, okay? How many milliseconds per image, right? On a V100 GPU. This is the NVIDIA V100 GPU. Okay, and you can see the increase in the performance as well as accuracy. So that is what we need, and that is especially needed for our diabetic retinopathy or any other medical imaging task as well, because where we need we have to have uh, certain hardware to be implemented in a local environment. So we cannot afford, in India especially, we cannot afford a huge server machine that is to be used for processing all this information. Okay, yeah. So this is the pipeline. This is the actual generator I just generated it in last hour using ChatGPT, and it is quite nice. You can see the data collection is shown here, and pre-processing is shown there, and then the input preparation in case of your partitioning, like uh, patches are being prepared, and then patches are being fed into a standard VIT or a swing transformer model. And then you have the classification head predict all the 5 classes here, and then you can have the final prediction there. Okay, so and training process is given here, and then the deployment is required. So we have to assist the doctors to say that okay, this person is having a severe grade DR or lower grade DR, which needs to be treated uh, accordingly, or he doesn't have any retinopathy right now, so no problem. So like that. So these 3 categories are quite important. Once we have reached 4, then we don't have much treatment for that. Okay, so one more thing that we need to learn before we go into directly into our approach is this metric. So I hope that many of you might have already seen this metric, but we want to get the overview. It's a qualitative weighted kappa is a evaluation metric like your accuracy or F1 score or precision recall, AUC, and all those things. The only difference in this case is that instead of saying something is correct, something is wrong, it will also say that, okay, the rating is, let's say, for example, one first doctor is there, doctor one. Okay, doctor one is saying that he has seen the image, fundus image of a patient. He is saying that grade is 2. And another doctor, doctor 2 also comes and says grade is 2. Another doctor comes, says grade is 3. So all of them are almost grading it similarly. Okay. In case of accuracy, if you talk about accuracy, so this is correct. Maybe this is a grade 2. So this is correct. This is wrong. So accuracy only measures that, right? But in case of QWK, the quadratic weighted kappa, it'll measure the distance, okay, between the let's say agreements and disagreements. So they're actually the all the 3 doctors are actually quite agreeing to each other by giving the similar ratings. Suppose the third doctor is giving 4 and first doctor is giving 0. Then in case in case then this is wrong, this is correct, this is wrong in case of accuracy. But in case of your QWK, the quadratic weighted kappa, it is going to give a very negative score. Why? Because all the 3 doctors are disagreeing with each other for the particular image. So this is required. This is not only used for our diabetic retinopathy task. It can be used for multiple education, even in human evaluation systems. We can use, right? Education systems. Okay, of course we are using it for medical diagnosis, SS scoring, machine learning competitions, and so on. So this is to measure the agreement between 2 raters or evaluators. In our case, our raters are going to be AI, okay, those in transformer, and then the ratings are ordered in case of categories, classes, right? Okay, for 0 class to 4 class. So it is useful when the disagreement between the ratings should be penalized. Why that is required, especially in our diabetic retinopathy, is that okay, in this case we are entirely confused, right? Suppose let's say these 2 doctors are giving the and then the correct answer is 0. Let's say And this one, so 2 out of 3 is correct. So the accuracy is quite high, 2 out of 3. Okay, let's say there are 10 doctors and only two are giving 4 and others are giving 0, right? In that case, 8 out of 10, maybe 80% accuracy. So 80% accuracy means, okay, it is acceptable, right? To certain extent. But QWK is going to penalize the difference, okay, the rating disagreement between the raters. Okay, so that's why it is required. The intuition is two evaluators, okay, as I given earlier. Okay, if one gives 4, other gives 3, the disagreement is small. If one gives 4 and other gives 0, this disagreement is severe. So we have to, we cannot treat the accuracy in terms of accuracy only. We have to make sure that we treat them as a on accuracy will treat the mistakes equally, which is not correct, because larger the disagreements, larger the severity in case of medical diagnosis, right? Okay, and we have to use the weighted matrix, and the range of QWK is -1 to 1, okay, where 0 is chance. Okay, if you flip a coin and then give the rating, then you will get 0 in case of QWK. And if it is 1, then perfect agreement means that all the raters, all the answers are same and correct answers. All the raters are giving the correct answers and all the answers are same. Okay, usually we are looking for greater than 8, 0.8 excellent agreement, and if it is less than 0 means that it is even worse than random. So if you see this is the FDP, and if one of our students or some of our students are doing a machine learning project, and then some of them are giving accuracy less than 50%. So that means that their machine learning model is giving an accuracy worse than random. Random is 50%. So in case that it can also be detected by our TWK, and so I just wanted to introduce our the metrics which is usually used in medical diagnosis, and this is very much used nowadays, and we should also be aware of this. Yeah, so this is the work that I have been doing in collaboration with one of our BTech interns and one of the professor in Taiwan and me, and we are working on rating the DR across multiple data sets. Okay, as I mentioned earlier, these 4 data sets, and another thing that we are looking into is increasing the throughput. Okay, how much of images can be processed in 1 second, and so on, so that efficiency in terms of computation as well as the performance. Okay, our approach was using the swin large transformer. Okay, with using that we have been able to achieve a QWK score of 0.95, which is quite good, in one of the benchmark data set, and so on. Yeah, so this is some example, uh, uh, not example, the results. Okay, see the difference. Accuracy on accuracy on these 4 data sets. Only 63% accurate, maybe, in the ID data, right? But if you see the QWK, since the raters are agreeing with each other, the score is going to increase. Okay, so that is the difference. And then you have the F1 score, precision, recall, AUC, and other things as well. And this is one of the results that we have produced for the journal paper that we have submitted for publication. And then, yeah, the Aptos data set is using the QWK. This is a newer metric, but the older works are using AUC score for accuracy. Okay, so coming to the conclusion, okay, I'll just go to the demo as well. I still have 5 more minutes, I guess. Uh, So coming to the conclusion, the swing transformer offers a okay hierarchical multi-scale feature extraction approach, and it is a linear, okay, not exponential anymore. It is linearly computational linear complexity, uh, uh, making it ideal for clinical deployment, right? Because we need to have this kind of speed. If you feed one image into our CNN or a vision transformer, and if it is taking like 30 seconds to process, then it is not feasible, because we will have like 10, 20 patients waiting outside our door, and I'm taking like 1 to 2 minutes to just to get the results. So that is not a feasible scenario. So this is on a server GPU. So if you are going to deploy it in some sort of a embedded system or a portable system, then of course the time may increase, but it should take only 1 to 2 seconds to detect. Right. Okay. So that is one efficient model that we have to use, and yeah, so robust to other models as well, like CNN, and also it should maintain cross data set stability, meaning that if you are getting very high score in one data and then getting low score, same model is getting very low score in another set of data, then there is a problem in the model. So we have to have a cross data set stability before our deployment process. So this is, I'm not just talking about diabetic retinopathy, but I'm just generally talking about medical diagnosis. Okay, so I'll just come to the demo part. I'll just show you, okay, what, uh, okay, it looks like to actually implement, right? Okay, my screen is visible. I'll just connect to our server. Okay, this is our NIT server, and you can see, okay, we have GPU. We have a GPU of 16 GB or 15 GB. You can see the GPU model is also given here. So this is where we run our model. And if you want to actually deploy it, of course, we can connect to the server and then deploy, or we can compromise on the speed and then deploy in a local system as well. Okay, so coming to the demo, I have prepared a demo file. Okay, Rishikesh is the first author of our paper, as mentioned earlier. Yeah, so in this demo, we are going to load a pre-trained model. Pre-trained means we have already trained one model and kept the checkpoint. And then we have taken 4 samples for the demo purpose only. 4 samples, and then we'll be grading them. Okay, so this is the checkpoint. Okay, this is the particular checkpoint that we have loaded. And then for this particular checkpoint, these are the performance metrics. Okay, 80% accuracy with QWK of 0.85, quite acceptable above 0.8. And then the first image, okay, this is the image that we have fed in. This is actually in the server. I don't have the uh, GUI available with us. So the first image is this PNG, and this image will look like one of the image that I have shown here, already shown earlier. These images look like, this rolling. Okay, these are the images. Okay, .png in PNG form, and yeah. So the first image has no DR, as you can see, and with a confidence level of very high confidence. And the second image that we have taken, sample image, is mild DR. That is a grade 1 with a high confidence, and third image with high confidence. Refer to specialist. Why? In this case. Okay, we want the patient to refer to the specialist, meaning that he or she should visit the doctor and then see what will be the treatment that is required, right? To grade 2 and grade 4 as well. Grade 4 as well. You can see in the case of grade 4, you can see the confidence level is decreasing, and then some of the other classes are also getting scored there. So maybe we have to go to doctor and say whether I really have a grade 4, or maybe it's a misprediction by my AI model. So this is what we want to achieve. And coming to the code, I just wanted to show you the pipeline that I have shown earlier. Okay, the pipeline is okay. Yeah. So you load the model that you already have, that we have already trained with the checkpoint, with the best checkpoint that you have saved. And the pre-processing may be loading the image size of 224 by 224 as I've shown earlier, and then uh, removing unnecessary data and let's say making it into an array and so on for the processor. And then you predict, okay, you predict certain classes given the input. Where is the input? I think the input is already defined up. Yeah, so here. So these are the images, okay. The class is given, and then we are checking whether this is predicting the correct class. So that is the last one is also grade 4. So that is prediction of 80% accuracy. Okay, if I change these images, then it will detect different class. Okay, and then if you predict, and then you can display the results like this. So if we have a web deployment, we can connect to the server and upload the image, and then the processing will happen to compress that image or crop that image into a 224 by 224 pixel image to be fed into this, let's say, our model, and then the prediction will happen, right? Okay, so this is what I wanted to share, and then I hope my time is up. I didn't exceed my timing, so fine. Okay, yeah. Okay, and I use the help of Justin Johnson's Vision Transformer lecture notes from Cornell. And yeah, thank you. So I'm open to questions if questions.
Can you give more examples of what is the very key value in this particular use case?
Pardon, madam, I did not hear.
What would be the very key values in this image when you are
Uh-huh.
giving the diabetic retina to the image and you are grading it? So the labels will be the grades. So what are the very key values inside?
Okay, so query key values. Okay, this is a basic this one, right?
Mm.
QKV. QKV actually this is a part of a transformer model. Okay, if I have to explain, I'll just take it to some spaces there. So in a basic transformer model, we have to do something called as a self attention. Okay, in self attention meaning that suppose if you have this language, in language is easier to explain, which I'm taking language. So let's say this sentence problem tokens only interact with each other within the same window. So we have to find out the relationship between the token and other words. Okay, to the help of self-attention meaning that, okay, by looking into the same sentence with different aspects again and again, we want to learn, okay, the relationship between the words, the meaning of the words, and then also the grammatical nature of the words. Okay, so for that purpose, we are introducing something called queries, keys, and values. So these are actually building blocks of the transformer. So these are nothing but weights actually. WQ, WK, and WV. Okay, the weights of the transformer, and these values are not set by human. Okay, the AI engineers are not going to set these values. These values are going to be set by the initialize in any machine learning model. We are going to initialize it randomly or through some initialization mechanisms that we have uh, to some value, and we are going to learn it, meaning through backpropagation, through gradient descent. We are going to update these weights by through a self-supervised learning process. So these are not set by the human; it's going to be learned. So in this case, when we say about queries, keys, and values, these are actually going to interact with the same input. All three will interact with the same input. That's why it's self-attention. So although we have given these names, these are standard names from mathematics, but these are simply weights, and three sets of weights will maintain. and then one of the weight will represent the value of each word, meaning that whether this word is important, whether this word is important. In this case, if we see as a human, which words are going to be important? Maybe these words are important, communication across windows, may be important. Others, okay, tokens may be important, interact may be important. But others like the, with, only, okay, uh, other maybe may not be that important. So in that case, this value is going to, as you can see in the formula there, this value is going to be multiplied with some attention. Attention meaning that how much of attention I want to give to each word. Maybe I want to give high attention to token. Okay, maybe I want to give high attention to communication. Maybe I want to give high attention to Windows based on our understanding. So that will be computed by the keys and the queries. So these are all matrices. So the keys and queries, by passing through a softmax, they give you a, let's say, a probability, and then values will be multiplied with that. So once you multiply with the values with the probability, in this case maybe this is getting a probability of 0.7, and this case 0. Not 0.7, 0.3, 0.3, and 0.4, like that. Others are getting almost zero probability. That means that others are going to be suppressed, meaning that I'm going to lose the unnecessary information. Like that, similarly, we can apply that in our image as well. Which patch is important? If this patch is important, or if that patch is important, maybe the blood vessels are visible in this patch, maybe these patches are important, that will be your QK transpose multiplied by V software. So these are nothing but your weights of the network. So when we say pre-trained model, if we take a pre-trained model like a twin large transformer or a GPT 4.0 or something like that, these W, K, Q, V is already given by the OpenAI or another model. Or if in the pre-trained model that I have shown in the demo just now, if we take the checkpoint is consisting of all the trained models, WQ, WK, and WV. So this is what is given by the during the training process. Okay, madam.
I'm asking so initially when we are multiplying query and key, so that part is where we are getting the attention. So each word, what, we are looking from each word, what point we can give more attention to. And then after computing that, we are making it closer to the values. So similarly here, since it is a image with patches, what would you consider as an analogy? Like, what is query representing or keys representing in
Yeah,
images and patches?
yeah. So in case of images also same. If we actually in case of transformer, what we are doing is we are making this one is one token. So this particular word is converted into a vector. Here also it's a vector. So these are all same, exactly same as language. So instead of looking it as a image only, we can see it as a language. But yeah, so whenever we say value, we are simply talking about the actual value of that patch. For example, okay, for example, I'll just show you the image of. Okay, let's talk about this cat example. In this cat example, okay, I want to detect whether there is an image in the cat in the image or not. Okay, cat, yes, cat, no. Okay, so what are the patches that will have value? Maybe this ears, okay, maybe this area, right? So these are of very high value to us, right? For this task. Okay, so that is what your WV is going to represent. And then all the other parts are going to help us determine the value of each what is it? K transpose, right? V. Okay. So finally, initially we don't have any notion of value. So every pixel or every patch is same. But with the help of self-attention, okay, we are going to identify with the help of this QK transpose of max, we are going to assign each patch with some probability. Okay, probability in terms of how important it is, right? Maybe this part will have very high importance, right? Okay, like that. So finally, we'll multiply with the patch with each and every value of the softmax, and then we'll get the importance. So that this will do multiple times. Okay, because we'll have multiple layers, as you can see in the, yeah, we'll do multiple times in case if we miss something. So and in that case, in one block, okay, one self attention block here, you can see we'll have one set of QKV. Another will have another set of QKV. Another set will have another set of QKV. So in that case, one this in this case the value maybe it is detecting the fur. We don't know. Okay, and then next one is detecting the eye. Next one is detecting the ears. So like that. And like the same case in case of CNN also. CNN, if you see, visualize the its filters, uh, the features that it captures, you can see that it is sometimes CNN is detecting the vertical edges, the horizontal edges, okay, uh, the layout of the image and so on, right? So similarly, our vision transformer will also try to achieve that. Okay, in terms of image also same. In terms of language also, in case of language, maybe the thing that gives values in some layer is the grammatical structure. Maybe in another case the word meaning. Maybe in another case the let's say removing the stop words and so on. So every layer. So in that case, even in our swing transformer as well, we'll have the same different values. So whatever is decided at the end of the backpropagation, your our objective is objective or the loss function is going to say that this is a cat or not. If initially with some set of unknown QKV, if my model is saying that this is not a cat, but although it's a cat, then I need to change my QKV, right? Then it will keep on changing for multiple layers. So finally, okay, the values are going to be, let's say, in terms of colors or texture or or the diabetic retinopathy is trying to detect those, let's say, mm, the vessels, blood vessels, uh, and so on, right? So that's what usually happens in image as well, similar to language, right? So we are actually explicitly, I cannot say this part is important. It is going to be decided by the during the backpropagation process, during the gradient descent process. My weights will decide by itself. It's a self-attention. So during the supervised learning as well.
You have reduced the image size to 224, right? What is the time duration required for training for an idea data set?
Okay, time duration, I think, yeah, requires 18 to 12 hours of training for the
Okay. For 224 size images, how many images were trained?
image size. I have already given, I think, in the first slide. Image size is 224 by 224, as you have seen in the code, and yeah, so these many images for training and validation. 25,000, 3,000, 1,486 total.
And again, without resizing, nothing can be done, right? And we need that reduced size image.
Pardon, madam?
Right. Without reducing the size, can anything be done? Like any other possibilities there?
Without reducing the size, uh, no, this is standard we are taking. The 224 by 224 is a standard fundus image uh, size that we will be taking that. But in case of preprocessing, as I mentioned earlier, in case of preprocessing, where is that? Image that I generated earlier. Okay. In case of preprocessing, let's say we have deployed it. Okay, when you deploy, when the doctor is going to take the picture, the photo of the fundus of the eye retina, that image size may not be same as this, right? So if I take laser closer, it may be bigger or it may be okay. One person's camera size resolution is different from another person's camera. So during the pre-processing part, what we have to do is we have to segment that and make it into the size which is fitting going to fit my model, because my model takes only 224 by 220. That cannot be changed. So if the doctor is providing very smaller image, we have to enlarge it. If my doctor is providing a larger image, we have to crop it and make it to 224 by 220 for the deployment process. But the data is 224 by 220. Like for example, MNIST data is 228 by 28. It's a standard size. Yes, madam. Any other or any other questions?
If you don't, so if you don't have any question, if you don't have any question, so we will thank our expert, Dr. Denis Singh, for his valuable expert talk in the direction of healthcare research. So I would like to thank him for accepting our request for giving talk on a specific topic, and he has given, I feel that a core part of the image processing and their coding demonstration. I'm very much thankful for him for the demonstration with the coding and other details in the FDP. So thank you so much for sir. You no आ रहा है साउंड नहीं आ रहा है तो आ रहा है ना so I'd like to thank Dr. Dennis Singh for his valuable talk and also in details explanation about the problems and their coding. So thank you, sir. Now we'll take 5 minutes break and then we'll join again for the talk by Dr. Om Prakash Singh from Triple IT Bhagalpur. Thank you. We will take 5 minutes break. Thank you, sir.
Hello, Dr. Ujjwal sir.
Okay. Hello. So, good afternoon to all. Uh, uh, I want to introduce Dr. Om Prakash Singh for the talk. I'm happy that he have accepted our request to join in the FDP for so Dr. Om Prakash Singh is an assistant professor uh, in the department Computer Science and Engineering at Indian Institute of Information Technology, Bhagalpur, which is Triple IT Bhagalpur. Dr. Singh earned his PhD in computer science um, and completed his MTech from National Institute of Technology, Hamidpur in 2018. His research interests include information security, cyber cryptography, medical image processing and analysis, and deep learning. He has authored more than 62 scholar early publication in reputed peer-reviewed journal and as well as conference proceedings. So one, Dr. Singh is an active member of professional bodies like IEEE, ACM. He has contributed extensively to the academic community by serving as an technical committee member as well as the journal peer-reviewed journal reviewer in international conference and workshop in multiple capacities, including the session chair and technical program committee member. So I want to thank once again for him, and I want to request him to join and extend his expert talk for this faculty development program on the topic AIML in healthcare research, research trend, challenges, and limitation tools So in the intelligence system design for medical system. So thank you, sir, and please join and continue your talk, sir.
Yes, sir. Thank you, Ujjwal sir. My voice is audible to you, sir.
Yes, sir. Yes, you are audible.
So thank you once again for giving the opportunity for me in this FDP course. So once again, thank you for giving the opportunity like this. So it has been a very great welcome from my side. So now I will share my screen. So now, sir, my screen is visible. Hello. It is visible from your side, sir.
Yes, sir.
Okay, okay, sir. So now, so today presentation title is from my side is early detection of diabetic foot ulcer using the deep learning framework. So myself, Om Prakash Singh, and I'm working as assistant professor in CSC department of Triple IT Bhagalpur. So now, so what is the basic motivation behind this work? Why we have chosen diabetic foot ulcer detection? So nowadays we can see the medical domain, they are the various diseases that will be very impact on the human being that will directly affect their lifestyle. So basically, we know diabetic foot ulcer detection is the common diabetic complication that will be caused in terms of improper exercise if you not follow the diet plan and insulin therapy. So this is the basic complication that will increase the complexity of the common diabetes. And there is some facts related to diabetic foot ulcer detection. So in the International Diabetes Federation system that will identify that worldwide statistics in 2019, more than 463 million people will be affected from the diabetes, and which counts may be expected in the future is 700 million people that will be affected in 2045. So this is the basic stats why this disease is very important. And one more thing we have noticed is that every year nearly more than 1 million people will be the diabetic patient with have the very high risk foot ulcer detection that will lose their leg and to the difficulty for diagnosis and managing the diabetic foot ulcer detection. So this disease has very significant effect on the human being. And one more thing is first indication we can how to identify the diabetic foot ulcer detection. So with the initial stage we can see it is the initial drainage from the foot. There will be some pain and numbness and usual irritation will be there, some swelling, redness, and this is the very some initial stage we can identify this is the diabetic foot ulcer detection. So this is the basic motivation why we have to go and identify the early prediction of diabetic foot ulcer detection, which prevent the disease from the user. So if we early predict that disease, then that will be beneficial for the human being. So now, how can we recognize what are the basic symptoms related to diabetic foot ulcer detection? So we can see in the figure number 1. So there are the several. We can see this is the pain in your foot. Also, we can see the poor circulation of the blood inside the human body. Then we can say numbness. One more symptom we can identify, and dry skin. At least so this is the basic symptom which can occur in the diabetic foot ulcer detection. After symptoms of diabetic foot ulcer detection, then we have to identify what are the stages of diabetic foot ulcer detection. At which stage we can, if we predict early stages, then human being will be save their legs. So we can see this is the classification or different stages of the diabetic foot ulcer. So first one we can see this is the healthy foot in the first left hand side, and then stage 1 will be the mild stage. That will be a small partition will be the affected from the ulcer size. Then second stage we can say that is the moderate level, and third stage will be the several cases, so that will be entirely affect the whole leg, so that will be very difficult to retrieve the disease. So this is the basic stages of diabetic foot ulcer detection. Now, based on this problem statement, I have actually worked on the two methodology. What are the proposed solutions related to diabetic foot ulcer detection? So, in generally, the recent times research will use classification purpose if the patient have some diabetic or not. So they will use only some classification. So our work is not only classification. We have to identify the ulcer region where the ulcer part will be affected. So for this purpose, we have to use the develop some segmentation model. So YOLO V8 segmentation model. So this segmentation model not only to predict the location of the ulcer, but it will also identify the segmented region, which part the ulcer will be affected. So this and another work in the coding parts, in the hands-on parts I will discuss, that is the diabetic foot ulcer segmentation using the unit architecture. So basically our work in this PPT presentation is segmentation part, how we have to recognize the ulcers region. If we identify the ulcer region, then we have to use the XAI technique to visualize that part will be affected or not on the basis of feature. So now we have to move. So our first work, that is the proposed methodology, you can see in this figure. So basically we have considered some DFU data set. So these data the list of different will this data set then to
Hello, your voice is breaking.
40 close 640, and then we have to also perform vertical flip brightness normalization, so processing task that will enhance the pre-processing task. Then we have to apply some YOLO model. It is integrated with YOLO alone, and then we have to identify the backbone in the neck model, and the neck classes will feature fusion. So multi-scale box mask coefficient. And my voice is not audible, sir. Hello, Ujjwal sir. Hello.
Now audible, sir. No problem.
Okay, sir. But due to my internet activity, the voice is breakable right now, sir. Now my screen is visible, sir.
Yes,
Okay.
yes.
No problem.
Okay, some issue is from the internet side, from the network. So that's why.
No problem.
Okay, sir. So now the segmentation part, we have three classes: class box, mask, and boundary box. And then we have to perform the prediction part, and then we have to identify the final output. So the final output will not only identify the boundary box, but along with boundary box, we have to also identify the confidence score along with the area and the pixel value that will be the affected from the ulcer. So this is the generalized proposed diagram for we have to apply in the YOLO V8 model. So now, what are the basic operation we have to perform through the data description? So the data set will contain some diabetic foot ulcer images that will be available from publicly available data set repository. That is the DFU data set 2020. And then this image of content will some skin tone and lightning background ulcer images, and also collected from the different camera angle. So the data set will contain such types of information of image. And in the data set, we have considered that identified that total more than 1,000 original image will be prepared. And later on, then we have to apply some augmentation process to increase the sample size of the images. So after the augmentation, we have to total 2,400 images that will be good for the training. And then DFU boundaries are often irregular, difficult to localize. So using the rectangular boxes. So for this purpose, we have to go for polygon-based instance segmentation annotation will be used. So rectangular box is not sufficient. That's why we have to move forward the polygon-based segmentation model. Now we have to apply the annotation and label preparation, how we have to perform the labeling of the boundary box. So for this purpose, we have each ulcer region will be manually annotated using the polygon mask to capture the precise contour of the wound or the ulcer. And this annotation is will further converted into the format that will be required as the input of YOLO V8 segmentation. And single class level or ulcer will be used for the segmentation region. And this annotation strategy is particularly useful for diabetic foot ulcer detection because this lesser boundary usually irregular and critically important. So in the medical domain, each single pixel value is very important because if you altered or change some pixel value, then diagnosis will be occur. So that's why we have to perform the labeling with the help of polygon mask. And then we have to apply some pre-processing stage. So pre-processing will contain some image resizing. All the image dimensions should be resized with 640 with 640, and it will be given to the yellow V8 segmentation model. And then standardization is required to compatibility and network support efficient batch rendering. So this is the basic pre-processing task we have to apply. And then we have to for enhance the sample size to if the more number of input sample will be there, then diagnosis will be better, training will be good. So for this purpose we have to apply some data augmentation process with the help of various processing of image processing tasks such as flipping, rotation, variation with a different angles rotate. So we will enhance the sample size, that will be enhance the robustness of our different of our proposed model. Now we have applied the algorithmic steps how this DFU region segmentation will be applicable. So in the input, we have to given some DFU image data set with segmentation mask. So we have to given two input. We have to give the diabetic foot ulcer images along with the segmented mask value. And after the pre-processing stage, then we have to normalize the pixel value. So basically we have to divide it to 55 all the pixel value of the DFU. And then we have to apply the data augmentation with the help of various rotation and image processing operation. And then we have to convert the annotation task with the help of yellow V8 model. And then we will go for model initialization. Model initialization means that the yellow V8 segmentation model will contain the backbone, neck model, and the segmentation head. And then we will identify the pre-trained weights. That weights will be used for training purpose. And the training purpose, we will apply some for loop part that will be I belongs to I, that is the content of total images of the data set. And then we will extract the features from the backbone. And also we have to fuse the multi-scale feature with the help of PN feed neural network, and then predict the boundary box, class, score, and mask coefficient. So basically we have to train this model, and based on this model we have to obtain the final prediction with the confidence threshold value. So at the end we will achieve some diabetic foot ulcer segmentation that will contain the boundary box along with the confidence score and the pixel size. So this is the basic algorithmic steps we have to apply on the yellow beard segmentation model. So now you can see in this visual analysis of how this segmentation and boundary box value will be allocated. So in the first row, we can see this is the sample of original images. And then in the second row, that will be one boundary box, and along with the boundary box, the polygon mask segmentation. So you can see if the one number of ulcer is 1 in the first image, that one ulcer will be identified in the boundary box. Along with the polygon mask, we have to also identify the segmented mask area also. So in the second image, you can see this is the two ulcer. So we have to identify the segmentation with the help of two boundary box, and along with their boundary box and confidence score and pixel value and the area. So basically we will, in the last row, we can identify there if more than 3 ulcer will be there. So we have exactly identified not only one particular ulcer. If more than one ulcer is present, then our model is able to identify the boundary box along with the segmentation part. So this is
Audio
work, how this segmentation will be performed. And based on the segmentation model, we have to calculate the performance metrics in terms of precision recall, MAPS score. So you can see the nearby 190. Yes, the training and validation loss of our yellow beard model. So you can see the training box, segmentation box, class box. So this is the training versus validation. So each box loss function, segmentation, class. So this is the training and validation loss function related to our segmentation model. And then further, we have to go for comparison of recent deep learning model with our model, how our model will perform. So for the segment along with one IO score, we have to use different method and how this method will use the different architecture and which data set they have performed their performance. So you can see most of the data set will be used DFU data set or DFU 2021 data set. So in our case, we have achieved 96.2 dice coefficient that will be clearly identify the region of the segmented mask, and IU score is nearly 92%. So this is the some ideal value compared to the some recent work in 2023 to 2025. So this is one some comparative analysis with our work with recent technology. After that, we have also done one more work that will be the unit-based segmentation model. So in this case, we have to see that we have considered DFU 2020 data set. So that data set will contain the two inputs. First one is the input image along with their ground truth image. And then with the help of unit segmentation model, we have to predict the segmented mask. So in the second column, we can see this is the ground truth mask. And then we have to perform prediction mask. So how our model will train and then predict the predicted mask. So we can see ground truth mask and as well as our model predicted mask will be similar. So that means we can say we can predict correctly based on the given diabetic foot ulcer detection. After this analysis, we have also analyzed one more region. If the first column will indicate the test, and then after that the predicted mask, after predicted mask, then we will present the overrelay. So we will identify at which location our ulcer position will be there. So in the red color, we have to identify that we have to exactly locate the position of ulcer in the overrelay part. So this is one predicted analysis we have to perform through this in this diagram. So now let's wait. So now we have to, so basically this is main theoretical part, how this segmentation will be performed. So now I will move to the hands-on part, how these results and how this algorithm will be performed through the coding part. So I will switch on the coding part. So first I will show. So now my screen is visible from the coding point of view, sir.
Yes, sir.
So now, yeah. So first we will see in the Jupyter notebook. So we have written this code and the Visual Studio code. So you can see. So first we have to import the some library, and then we have to take the Kaggle inputs from the file name. So basically we have to access all the images from the data set. After installing all or considering all the images, then we have to apply some PyTorch that for the segmentation model, and then we have to install all the basic library file. So now we have to see in the import all the files, foot ulcer file, labeling, images, test, trading, label, and images. And then we have to what are the required library that will be used for. So we have to use some matplot library, PyTorch. And after for this argumentation process, we can see we have also used some library. Then segmentation model, we have also used segmentation model. So this is the some library that will be required for the segmentation purpose. Now for the define the dataset path where the training and where is the validation and where is the testing. So we have to create all the directory for this different training, validation, and test. So this is the some path how to allocate the directory. And then we have to identify total number of trained images we have considered is 810, and trained mask value is 810, and validation we have considered the image 200. So now we have applied some data augmentation because initially we have very less number of input diabetic foot ulcer images. So for this purpose, we have applied here. Sir, wait for a few seconds. sir, my mouse is not working, so please wait for few seconds, sir. So now, yes, so now it is working. So first we have to apply the some argumentation pipeline. So you can see we have to perform the various argumentation
Audio is breaking, sir.
size,
Hello, sir.
then we have to apply some vertical flip, and then we have to perform the random rotation contrast, and then we have to also perform the some. Yes, sir. It is visible my screen or voice is audible? Hello, sir. My screen is visible. Hello.
Not visible.
Wait, sir. Wait. I can reconnect, sir. Wait, please. Now it is screen is visible.
No, sir.
Hello. Still is not visible. No, I am not sharing the screen. Kindly allow to share my screen. Host is not able to sharing the screen, so kindly allow me to share the screen.
Sir, just try now, sir.
Yeah, I am able to share the screen. Thank you. So now it is visible. Hello.
Yes, sir.
Yeah. So
Yes, sir.
basically we have to
Visible.
start the augmentation. Yes. Thank you. Now it is first we have to start the augmentation process. So we have to apply the resize, then we have to perform horizontal flip, vertical flip, random rotation. Then we have also performed the brightness contrast. Then we have to apply some affine transformation, and then we have also performed the normalization. So basically we have applied the different types of augmentation process to increase the sample size, that which ensure the better robustness for the deep learning model and give the better results. So now we have to further, next step is we have to create the dataset class. So for this we have to make the directory will contain the image directory, mask directory, and augmentation. After creating the file list, then we have to take the image path and mask path, and then we have to read the image with the help of IM read, and then you have to identify the color image, then you have to write RGB, and then we have also read original ulcer images along with their mask value, and then we have to perform the normalization, and that it will be divided by 255.0, that will transform the pixel value into 0 into 1 form, and then a self augmentation pipeline will be there, so that will augment the sample size and mask value. After that, we will, after the augmentation process and normalization, then we have to go for the training and validation data set. So for the training data set, we have to use some image directly and mask directly, and then we have to for the validation part, we have also identified the image directory and mask directly that will be used. So now we have to create the some data loader part, that will be the batch size and the number of network workers, and then we have to identify the validation part. So similarly, we have to identify. Then we have to visualize one sample one by one. So basically, we have to figure the training also data set and the mask value. So now you can see this is the some put images, and this put image, the initially the mask value along with the mask value that will be given. So in the data set, both images, ulcer images along with their mask value will be given. So we have to display that images. Then we have to apply some resonate model, unit model. So now you can see we have to apply the segmentation model, and then we have to name the encoder weights, and then we have to take the number of channel and classes. So basically, when we apply the unit segmentation model, so we have applied two model, resonate 34 and then efficient B4 model. So these two classification model, these two method will be applied, and then we have to use some loss function. So, and this loss function is dice loss function, dice coefficient loss function, and binary cross entropy loss function. And then we have to identify the loss function. So this is the loss function here, coding is there. And then we have to perform some optimizer part. So now we have to ulcer segmentation model optimizer, Adam optimizer will be there. And then we have to go for training part. So in the training pass, we have to apply the total number of epochs 40. So now we have to apply the one for loop from 1 to 40, and then we have to go for training part. So that will be train our model. After the training, then we have to go for validation part. So that validation model will be also performed. And based upon this training and validation, then we have to identify, we have to go to the epochs 1 to 40. So this is the training loss and validation loss. So after, at the end of 40 epochs, then we will achieve the training and validation value. And then we have to plot the curve for the training and validation part. So we can see, and for the figure size, we have to training and validation. So you can see this is the training and validation loss function. So we have to apply the total 40 epochs. Based on the 40 epochs, we can see the y-axis, that will be the loss function. So this is the training loss and the validation loss. And after that, for the image segmentation, we have to calculate two performance metric. That is the one dice coefficient, dice score, and then IU score. So now we have to apply the dice coefficient. So basically, how to evaluate the dice coefficient, that will be given the two parameter, that is the prediction comma target. So basically, based upon these two, we have to identify the dice coefficient, how they cover the intersection region part. So now we have to apply the sigmoid prediction part, then we have to perform the prediction if value is greater than 0.5, and then we have intersection part, that is the prediction into target, that will give the intersection. And then we have to calculate the dice coefficient, that is the formula for, you have to apply 2 into intersection divided upon the prediction of sum plus target of sum. So that will be calculate the dice coefficient. And then we have to evaluate the model segmentation, then we will achieve the validation across score is 90.90%. So that is the validation dice coefficient score. And after this dice coefficient analysis, we have also performed the various other performance metric that will be useful to predict the other performance model. So now we have to calculate precision, recall, F1 score, and IU score. That will be the, so this is the basic mathematical formula we have to apply, and then we get the result. So now we have to compute the accuracy. So now you can see, so the pixel accuracy is 99.78, and then we have to also calculate the G-flops times. So what is the computational time, that will be also indicated in this. And then, so G-flop time is 31.42 second, and then total number of parameter for this training is 24.4 million parameter. So according to this parameter, we have to also calculate the G-flop time. And then we have to further final ulcer segmentation model. So we have to evaluate all the evaluation part in terms of dice coefficient, IU score, precision recall, and F1 score. So this is the performance metric we have to perform. And then we have to also identify the bias coefficient. So you can see validation coefficient is 90%, validation IO score is 82%, precision is 95%, recall is 86, and then we have to F1 score which belongs to 90%. And apart from that, we have to also identify the boundary box of the confusion matrix. So you can see for the confusion matrix part, we have to obtain, and then also we have analysis one more terms here. So you can see, so now we can see this is the original image foot ulcer images along with the ground truth value we will be given in the data set. So the data set will contain to a number of ulcer images along with their ground truth value, and then we have to apply our deep learning model to predict the segmented mask. So you can now visualize this is the original image and this is the ground truth, and then this is the predicted mask. So predicted mask will be there. So now you can visualize this is the similar like ground truth image. So you can see we have tested so many images, original images, ground truth mask, and this is the predicted mask. So now you can visualize this is the different kinds of images, and we have to predict the segmented mask. So the segmented mask, predicted mask will look like similar. So this is the first unit model we have to apply. And then we have to also identify the XAI technique that will be beneficial for identify how this segmented mask will be appears, how this will be feature will be identify the localization of ulcer. So for this purpose, we have to apply the grid cam. So grid cam will be also useful for identify the feature where whether the ulcer will be predicted or whether the ulcer will be affected inside the foot. So you can see, so some images will be good for the identify the grade cam. So at this point, there is one point will be identified. Apart from this, there is one more region will be identified. You can see in this image that part is the ulcer, and that ulcer part will be affected. So in the features in the red color zone. So that is the heat map through the gate cam analysis, and we have also identified the overlay. So some images it will correctly predict at which location ulcer will be affected. Somewhere it will not correctly work. In this case, you can see this is the part of the ulcer that will be localized by the heat map visualization. And in this image, it will also perform better. So some images it will good at this point. It will also identify it is correct one. So this is the heat map visualization, whether on which basis our ulcer position will be correctly located or not. So this is the heat map visualization. And then we have also visualized our data. So for this segmentation model, we can also use, you can see this is the tested image, and this is the predicted mask by our model, and then we have to replay the overlay. That will be the red zone part you can see in the at the ulcer position. So that how the predicted mask is correctly identify the ulcer or not. So this is the overlay part. So you can see this is the tested image, this is the predicted mask, and this is the relay part that will cover all the part of ulcer. That part is not correctly because it is not identify the side that one. So that part is false from our side. These images it will correctly identify the predicted mask along with the red color that will indicate at the correct position of the ulcer. Similarly, for these images, it will correctly perform. So this is the basically predicted how the predicted mask along with the overlay. So we have tested so many images and identify which one is the good for identify the overlay part. So this is the analysis part. And then we have to save all the images through in the zip folder. So for this part, we have to apply. So this is the unit model you can see. So this is the first work. We have applied some unit model to identify the segmented mask and predicted mask. One more work we have to also apply here with the help of YOLO V8 segmentation model. So you can see here. So now in the second work, we have applied the YOLO V8 segmentation model. So we can see the initially we have import all the library file. Then we have to apply the path for saving the image from the directly predicted mask and the original image. And then we have to reach the image with the help of imread function. Then it will transform into the RGB format. And then we have to also give the mask value, and then mask value will be converted with the help of normalization. If the mask value is greater than 0.5, then it will be converted, and then if it is required to resize, then it will perform the image resize, that is the original image width and height. So image size will be similar. And then we have to apply the basic leveling with the help of, so we have to apply the contour, that will be the approximate retailing value. And then we can see this is the coordinate value after perimeter and area, how much area will be covered and what are the pixel value. So basically, and then lastly we have to combine the mask value. So this is the basically. So now you can see if one image will be there, then we have to identify this is the ulcer, and the confidence score will be so 0.96. Similarly, you can see this is the more than one ulcer value will be there. So they are the three ulcer in the original images. So we have to predict all the three ulcer and identify the confidence score. Similarly, for the similar image, next images. So this is the way we have to identify the ulcer. So, and then we have to apply the prediction part. So prediction part, we have to say we have to given the image link, RGB image, then draw the mask with the help of contour. And then we have to draw the boundary box, rectangular boundary box. So we have taken the coordinate value, and then we have to identify. So now you can see, so this is the first real images, and these real images we have to identify the boundary box along with the polygon segmented mask. So that will contain the confidence score and what is the area, and then it is the pixel value, total pixel value that will be covered in the size of ulcer. In the second images, we have to also apply the yellow bead model, and then we have to first identify the boundary box, how many number of ulcers. So in this image, we can see there are the three different size of ulcer, and all these three ulcer will be recognized in the boundary box along with the segmentation mask. So that is exactly or correctly, precisely manner the all the predicted mask. Similarly, in this case, we have also identified. So we have tested so many images that will recognize the ulcer and predict the correct position and identify the polygon shape, whether the instance of the segment ulcer. So you can see if it is a single ulcer, that we need to so exactly identify. In this case, we can see also this is the confidence score and the area of size. So we have identified the yellow bead model that will exactly localize the ulcer with the help of boundary box. Along with, we have to also segment with the color, with the help of blue color. So this is the yellow bead segmentation model result. And then this is the code for yellow bead segmentation level, how this labeling will be performed, how the polygon mask will be recognized. So you have to apply the for loop for identify the mask value, and then lastly we have to append with class ID with polygon mask. And then we can see the next we have to identify the mask value, polygon normalized, and image size. So we have to identify the number of images, and then total number of polygon of two masks, and then we have to identify. So in this case, we have achieved the IOS score is 80.5, 85% for average IOS score. And so this is the basic generalized yellow bead segmentation model that will be not only for localization of the ulcer, but it will also identify the segmented part of the ulcer. So basically, we have applied yellow bead segmentation model, first work, and second work is we have applied unit model for segmented the ulcer. So this is the two work we have to integrate it in this PPT presentation. So this is from the code implementation part. I will share if anyone is required or if anyone is needed. So from my side, it is the hands-on along with the theory part. That is the part from the diabetic foot ulcer detection using deep learning model. So now, Ujjwal sir, if any doubt is there, if any question from my sides, then a student will ask from anyone.
Yes. So I would request to all, if any question to Dr. Om Prokar Singh, Assistant Professor, Department of Computer Science, IIIT Bhagalpur. So you can ask now.
Sorry, Ujjwal sir, basically my internet connectivity is low because some cyclone is there from IIIT Bhagalpur. So we are very facing the internet connectivity is very low from my side. So that's why there are so many disruption from my side, not visible with the PPT, not audible sounds. So it is my fault.
No, no problem, sir. It's fine, sir. Yeah, we know that there are some problem in online mode also, but it's fine, sir. You done well, sir. Thank, thank you, sir, for
Thank you, sir, Ujjwal sir, for giving the opportunity in this FDP course. It will be very good from my side. It will interact with you and all the participants. So it will be very good from my side. So I would like to thank you once again, Ujjwal sir, for giving the opportunity to participate in this conference. So thank you once again and all the participants. Thank you, sir.
so. Uh, Thank you so much for your this talk. As there is no question, so officially I thank Dr. Om Pukar Singh from Triple IT Bhagalpur, Assistant Professor. So he has accepted our request. So I'm very thankful for him for the sessions, and as well he in his talk I seen that there are many practical things he demonstrated. So it is good. I feel that this is learning. So you can learn and you can talk with him also. You can mail him. That is good that we have collaborated and we have given the opportunity to introduce you also here in this FDP. So thank you so much, sir. Now we are going for 10 minutes break. We'll start again around 3:15. So 5 minutes late. So it should be on 3:15 or 3:20. So by this 3:15 on 20, we will rejoin and we will start our valedictory session. So I'm requesting all the participant don't disconnect. You continue, but the valedictory session will be start from 4:20. It is better to say 4:20 because it is only 3:07 now. So at least 10-13 minutes is required for the break. So I will request all to rejoin in the time at instead of 3:10, it should be we are starting from 3:20. Okay, thank you all. So, sir, also please you stay here.
Yes, sir. Yes, sir.
So,
Thank you, sir.
we are going for break 15 minutes here, sir. Okay,
Okay.
so. Please check that sound is coming. थोड़ा सा पीछे रखो। Yes. Fine. Check the sound also. Yes. So, very good afternoon to all. I am Dr. Ujjwal Vishwas, one of the coordinators for the Faculty Development Program. Respected dignitaries, distinguished resource person, esteemed faculty members, organizers, participants, ladies and gentlemen, good afternoon, and warm welcome to the valedictory function. It is indeed a privilege for me and an honor to stand before you on this valedictory occasion of the 5 days hybrid faculty development program on the topic AI and machine learning based healthcare research tools, trends and challenges in intelligent medical system, jointly organized by the National Institute of Technology Manipur in the association with the Department of Artificial Intelligence and Data Science, Jyothi Engineering College, Thrissur, Kerala. As we come to the conclusion of this enriching academic journey, it is time to reflect upon the knowledge shared, the idea exchange, and a truly inspiring session provided an excellent platform for exploring how artificial intelligence and machine learning are shaping the new era of healthcare research and intelligent medical system design. So the program began with an inspiring inaugural session, keynote and presidential address by the Honorable Director, Professor D.V.L.N. Soumajulu, Professor Kaimantam Mangalam Singh, and Professor Prahlada Rao, DB, from Department CSE, NIT Manipur, and Father Dr. Jose Kannam Pahuja, Academic Director, Jyothi Engineering College, Dr. P. Shajal Lal, Principal, Jyothi Engineering College, Dr. Khelchandra Thangbang, Academic Dean, and Dr. M. Jeena Channu, Associate Professor and the Head of the Department of Computer Science, who shared their visionary perspective on the AI application and ML in healthcare research to encourage the participants to emerge into the innovation and interdisciplinary collaboration. We are privileged to gain a valuable insight into the research direction in quantum machine learning, robotic application, wearables, and remote patients, AIML, patients monitoring, and also intelligent computer-based technology in dentistry and healthcare system, deep learning in healthcare, generative AI in preliminary disease diagnosis, and transformer-based grading of this diabetic retinopathy. These are the major highlights of our faculty development program. Now, reminding us of how digital intelligence is revolutionized and transmit the planning and patient care in the healthcare research. So now I would like to express our heartfelt gratitude to all the distinguished research persons from across India in various states, their expertise, experience, and valuable insight. Their dedication and scholarly contribution have made this program successful and truly meaningful to us. I also extend sincere appreciation to the organizing institute, coordinators, faculty members, technical staff, volunteers, and my students whose participation make it meaningful faculty development program and seamless execution of the program ensure the success of this hybrid FTB and organizing academic program of this nature requires a commitment from teamwork and vision. I would like to mention in this direction the principal of Jyothi Engineering College, Dr. Sujan Lal, for his joining hands with us for the faculty development program. To all participants, congratulations for your enthusiasm and participation and commitment to continuous learning. The true success of any FDP lies not merely only the attending the session, but applying the acquired knowledge to teaching, research, innovation, and collaboration. So, collaboration is one of the key facts which is built during the session. I hope this should be extended more and insightful gain here will inspire meaningful contribution from all in future in the healthcare, artificial intelligence, and interdisciplinary research as well. As we conclude this program, let us remember that learning does not end here. Instead, this marks the beginning of the learning of new ideas, new collaboration, and new research pathways. May we continue to explore, innovate, and contribute towards the nation in the direction of smarter, ethical healthcare, inclusive healthcare system empowered by the intelligent technology. Now, I would like to invite our respected professor, Dr. Kaimantam Mangalam Singh, as he is here with us. He is our respected professor in the Department of Computer Science to give some words to inspire our dignitaries and also the research person from his point of view. And also, I like to invite you for some few words towards the faculty development program. Sir, please come.
Good evening, everyone. We are coming to the end of 5 days faculty development program today. And the program actually is AI and ML healthcare research. And I would like to really thank all the dignitaries who are present, our faculty members, including our coordinator, Dr. Ujal Vishwas, our ISPDs, Dr. Dinachanu, our expert who have given talk, Dr. Dennis, and Dr. Anil Kumar Viru from Mechanical Engineering Department, Dr. Kelchandra from Din Academic, of course, she is a faculty from the Science Engineering Department, and the expert from Jyothi Engineering College, and expert from others, and our staff members from computer science engineering department, and our students and participants. Of course, I could not in the workshop. Of course, I was there at the beginning. In the later days, I could not present in the program due to other work. And many experts have given very interesting talk. All those topics are related to their work, their research areas, and applications of AI and ML. This will be, I think, will be very much useful to many of the participants, and I hope they will use whatever the knowledge they have gained here in their research work and other applications. Of course, this is not the end of the program. In future also, we hope we'll be organizing many similar workshops in this area and other area that will be useful to many of the participants, even our faculty members and other people. I do hope we'll continue the same spirit to do research in AI and ML in future also. With this, I would like to thank everybody. Thank you very much.
So, thank you very much, sir, respected Professor Koimantam Mangalam Sheen, sir, from the Department Computer Science and Engineering. On behalf of all department and also director, because today all are busy due to some Senate meeting at our institute. So I'm very much thankful to him, as instead of his busy schedule also he is there to inspiring us and for the participant as well. So I am very much thankful for him for the valuable words towards the faculty development program. And he also mentioned that in future this is not the end. I have also shared that this is not the end, this is a beginning, and we will collaborate. That is the actual objective of the program, any faculty development program. So collaborating is one of the most vital part of this. In the keynote address also, our director said extends the word that collaboration and other thinking about the AI tools and other things should be there in faculty development program. So I'm very happy if anyone from these participants or any college from that wants to collaborate with us also. So very much thankful to the sir. And now I would share a very important thing, which is this as a FDP participation analysis based on the data analytics. So I have planned that I will share. This is very important, and I have some very important observation on the participants. So this is the analytics, and based on the participant data, I have observed that mostly participants are from female candidates. If you check the participant registration rate, this is 73.3% female participants participated in this FDP. I'm very happy that in India, across the state, and here also I have mentioned the statewide registration as well, and I have to observe that in this registration or faculty development group. So I feel that there's now is fine. So I feel that now this ratio of male is 26.7% and female is 73.3%. Now across This state data also I have mentioned from Kerala, then Manipur, then Karnataka, Andhra Pradesh, and then Rajasthan, then Jharkhand, Odisha, and also from other states. So these are the major states, but I feel that it is count 10, but more or less it is around 15 state faculty members and students participated in the program. So I'm very happy to see these statistics as well. So and another important parameter of the registration, I observed that most of the participants are from assistant professor. If you check, this assistant professor is written in different abbreviations. So I have get at least three types of assistant professor written. All are capital assistant professor. So mostly all participants are assistant professor, and few associate professor. Associate professor is around 60. 16 participants are associate professor, and also professor are five professor participants in the faculty development program, and student mostly these BTech and MTech student and research scholar. So I am very happy that all participants are from the assistant professor category. So checking these across state and these participation from the faculty development into it is very encouraging for me also. Another important thing also I observed that during the registration process, it was started in the very on 7th May in this month. So everyone querying to me that you have given very short duration. So yes, it is very short duration. For the last date, it was last date on 17th, but due to the major requests from other state as well, I observed that I have extended and we have extended the deadline for the participation. So I feel that that is our gap. Maybe in future, if we organize such program from the coordinator point of view, I will keep in mind that at least it should be of this 15 days gap for registration. It should be like this. So from that direction, it is very good that the number of faculty registered. Now we are pleased to take feedback online or offline. Those who are here personally, if you want to share your view and feedback, so those who are, I will take online feedback first, then I will take offline feedback from my institute participants. So if you are online, so any type of feedback should be accepted and should be addressed. So can you please share your actual feedback about the theme, about the session, about the organization, anything you can discuss openly. And this is now open for the platform to discuss about the positive or negative feedback on the faculty development program, so that we can make it more reliable and good for the future generation. So it is open for the open feedback from the platform. So is there anyone from the online participants, anyone wants to share your view? So so no one from the participants interested to share your view and the feedback.
I am Dr. Umesh Kumar from Jharkhand, Kodarma.
Okay, go ahead, please.
Yeah, please. So this 5-day FDP, what we have done in AI and ML, lot many FDPs are currently going on, but particularly in the area of medical and healthcare, this was the first FDP I could think of. It has given us very insight and thoughtful processes for continuing major researches, you can say, in these particular areas. The topics selected by you were excellent. The experts, those who have given expertise lectures, particularly the jobs what they were doing themselves, that was remarkable. So such type of FDPs are really welcome, and we are inspired. Thank you. Thank you very much for the smooth conduct of this FDP. Thank you.
So thank you, Dr. Umesh Kumar. Thank you for your valuable feedback. So we will definitely go forward for further any extension of such programs from like NIT Manipur side. So our respected Professor Kaimantham Mangolam Sim also mentioned that this we will continue. Okay. So thank you for your valuable feedback. So anyone from other?
Good
Then
afternoon, sir. I am Shweta, and
okay,
I would
good
like
afternoon.
to share my feedback regarding the FDP. And this FDP on AI/ML based healthcare research tools, trends, and challenges in intelligent medical system was highly informative and enriching. And this session provided valuable insight into the latest application of AI and ML in the healthcare research. And through the practical examples and discussion on emerging trends, the program was very well organized and academically beneficial. A special thanks to Dr. Ujjwal Vishwaskar for the excellent coordination and a smooth conduct of the FDP. Overall, it was a wonderful learning experience. Thank you, sir.
So thank you, Sweta, Shina. Uh, yes, I am getting some good feedback from your side, so I am also happy to see this. Uh, Check this feedback also. So thank you so much for your feedback. Now, next, is there anyone want to share your feedback? So please give us feedback so that it would be good for us and the participants. So please give feedback. Anyone from the online participant? So if no one dare from this online mode feedback, so I will go for this offline mode feedback here at NIT Manipur. So I will request those who are here also at NIT Manipur, those who have means participated hybrid mode. So can you share with us some few words related to this faculty development program? Come forward and say something about the topic and about the FDPs. Please come.
Audible? So, good evening, everyone, all respected dignitaries. So, good evening to everyone, all respected dignitaries, honorable professors, faculty members, and my dear friends. So, എല്ലാവർക്കും എൻ്റെ നമസ്കാരം. So, it's before I say that about Jyothi Engineering College that I went through last year, Thrissur last year, and it's a nice place. And after that, I would like to tell that about that workshop that it is my privilege and a great honor to share my feedbacks regarding the highly enriching 5 days faculty development program on AI and ML based on healthcare research, tool strengths, and challenging in intelligent medical systems. So I have written what was the, according to the day wise, what was I gained learned from this workshop. So on day one, our sir, Dr. Ujjwal Viswas sir has included about AI and ML based healthcare research and future healthcare technology. So from that, I got understood that how intelligent systems can improve disease diagnosis, about healthcare and medical decision making, which creates a strong fundamentations for the upcoming sessions. On the second day, from the Jyothi Engineering College, Dr. Jatin Kesi sir has introduced about AI ML in intelligent healthcare systems, tools, and training robotics applications, which helps me to understand about how intelligence, automations, and robotics can change the healthcare ecosystem. And the second half, Dr. Sajita A.S. ma'am explain about the future wherever artificial intelligence and remote patient monitoring, in which I get to know that how healthcare is gradually become smarter, personalized, and patient-centered through the technologies. On the day three, our Professor Sir Prahlad Rao, BB Sir, discussed about AI/ML direction about quantum computing. In quantum, basically, I don't know about quantum mechanics, but before after that, Ujjwal Sir and Prahlad Sir, I gained lots of knowledge about computing in quantum. So it's helped us to understand the future possibilities of advanced intelligent systems and the healthcare innovations. So in the second half of day three, Dr. Sania Fenis ma'am has introduced about medical image segmentation from unit to foundation model, which shows us how advanced deep learning technologies are improving in medical imaging and disease detecting with a better accuracies. On the day four, our Dean Sir Khelchandra Thangam Sir explained about deep learning and the intelligent application in healthcare, which I got gain a knowledge about how intelligence models can identically hidden the health patterns and support the early diagnosis. After that, on the second half of yesterday, therefore, I gained knowledge from Dr. Ujjwal Biswas sir about quantum machine learning and generative AI in the privileging uh, disease diagnosis, which helped me to broader visions of how next generation of AI can regulate medical diagnosis and intelligent healthcare. And for the current day of day five, our Danish sir explained about the transformer-based medical facilities in which he demonstrated how AI can help in eye detections of health disease. And in the second half, Dr. Om Prakash sir has given us a knowledge about how beautifully summarize the transformation role of AI in the modern medical. So apart from that, I would say that I am also working on the healthcare using deep learning. So I will also work on that. And with that workshop, I gain a lot of knowledge, and it will be helpful for me in my project. Thanks to all. And in Malayali, I would say that Vadle Nandi, everyone.
Thank you, Dr. for such a wonderful workshop. This AI workshop is very informative, engaging, and relevant. The session explains the key concepts that you should I hope it's the
Good evening, everyone. Am I audible? Hello. Good evening, everyone. First of all, I would like to express my sincere gratitude to the Department of Computer Science and Engineering, National Institute of Technology Manipur, and Jyothi Engineering College for organizing the wonderful faculty development program on artificial intelligence, machine learning, quantum computing, robotics, and intelligent healthcare system. This FDP was highly informative, inspiring, and beneficial for all participants. Throughout these 4 days, these 5 days, we learned many advanced technology and their real-world healthcare application from respected professors and experts. So on day one, the program was inaugurated with inspiring addresses from Professor D.V.L.N. Soumya Dulu sir, Director of National Institute of Technology Manipur, Gina ma'am, Head of Department of CSE, Professor Mangalam sir, Professor Prahlad Rao Bibi sir, and faculty coordinator including Dr. Ujjwal Biswas sir. An overview of Jyothi Engineering College was presented by Dr. Jose Kanan Fuja sir, Academic Director, while the presidential address was delivered by Dr. P. Sojan Lal, Principal of Jyothi Engineering College. On day two, the second day focused on robotics, wearable healthcare technology, and remote patients monitoring system by Jitin Kesi sir explained robotics concept, healthcare robotics application, and tool such as Google Colab, NVIDIA Monai, BioNemo, MATLAB, Webbots, uh, and Orange data mining.
Box files and very great.
Data man,
System.
uh, Dr. Sajita ma'am discussed wearable healthcare devices like IoT, Edge AI, federated learning, and predictive healthcare system using AI models such as CNN, LSTM, Random Forest, and SDM. On day three, the third day focused on quantum computing in healthcare, medical image segmentation, and intelligent dentistry technology by Dr. Anil Kumar Viru and Professor Prahlad Rao sir explained quantum computing application in healthcare, including drug discovery, genomics, medical imaging, and quantum neural networks. Dr. Sinia Francis conducted a session on deep learning and medical image segmentation, covering CNN unit, GNS, vision transformers, SAM, and on the MONAI framework. Dr. Anil Kumar Biru also explained intelligent dentistry technology using CAD CAM and treatment planning. The 4 day session was conducted by Khilchand sir and Ujjwal Biswas sir from NIT Manipur. Dr. Khilchand sir explained artificial neural network, uh, backpropagation CNN, faster RNN, and healthcare application. And Dr. Ujjwal Biswas sir introduced quantum machine learning application in healthcare security, medical image watermarking, uh, and diagnosis system. On day 5, the fifth day session were conducted by Dennis sir and Dr. Om Prakash Singh sir, focusing on advanced deep learning and transformer-based architecture for intelligent healthcare system. Dr. Dennis sir explained modern AI models such as Swin Transformer, hierarchical multi-scale feature extraction, and Dr. Om Prakash sir presented research-oriented concept related to diabetes, food ulcer, segmentation, and medical image processing using deep learning. So overall, this FDP was highly informative, inspiring, and beneficial for all. It successfully connected theoretical concept with practical healthcare application while highlighting important topics such as responsible AI, data privacy, fairness, explainable AI, and healthcare security. Personally, this program increased my interest in artificial intelligence. So I sincerely thanks all the represented resource person. I also extend my heartfelt gratitude to all coordinators, organizers, and faculty members and technical team of NIT Manipur and Jyothi Engineering College of successfully conducted this FDP. Thank you, everyone.
So thank you all. Wishing everyone success, good health, and continued academic excellence. Now I would like to invite our research scholar in the Department Computer Science of Engineering. In absence here of our HOD, Madam, she will give a word of thanks to all the dignitaries, participants, and the experts. So please come on the dais. Please salam Shormila Devi for his valuable word of thanks speech. Please come forward.
Thank you, sir. Good evening to everyone present here. It gives me an immense pleasure to propose the vote of thanks for this 5-day hybrid faculty development program on AI and ML-based healthcare research, two trends and challenges in intelligent medical system, jointly organized by the Department of Computer Science and Engineering, National Institute of Technology, Manipur, and Department of Artificial Intelligence and Data Science, Jyothi Engineering College. First and foremost, I would like to express my sincere gratitude to our Honorable Director, Professor BBLM Somaya Julu of NIT Manipur for delivering the inspiring inaugural and keynote address and for motivating us towards advanced research in AI and healthcare. I would also like to extend my heartfelt thanks to Professor Kumanthem Manglem Singh of NIT Manipur for presenting the overview of NIT Manipur. I would also like to thank Professor Parada Rao BP of NIT Manipur for the welcome address and for sharing valuable insights on AI ML research direction and quantum computing. Dr. Jus Kanmapuha, Academic Director, JAC, for the overview of JAC Trishul. I would also like to extend my gratitude to Dr. P. Sozan Lal for the presidential address, Dr. Khelchandra Thongam, Academic Dean, NIT Manipur, for the session on AI and ML-based healthcare research, future perspective and DL and intelligence application in healthcare. And also, I would like to thank Dr. Yambem Jina Chanu, Head of Department, Computer Science and Engineering, NIT Manipur, for delivering the vote of thanks. I sincerely thank all the distinguished resource persons for their highly informative and enlightening session. With due respect, I mention this expert, Dr. Anil Kumar Viru, for the session on intelligent computer-based technologies in dentistry, Dr. Jiten Casey for AI ML in intelligent healthcare system, tool trends and robotic application, Dr. Sajita AS for the insightful talk on the future of healthcare, wearable AI and remote patient monitoring, Dr. Sinia Francis for the excellent session from UNED to foundation models, evolution of medical image segmentation, Dr. Ujwal Biswas for the informative session on quantum ML and Gen AI in preliminary disease diagnosis, Dr. M. Dennis Singh for the session transformer-based automated grading of diabetic retinopathy, and Dr. Om Prakash Singh for sharing his expertise on application of deep learning models in healthcare. I would also like to thank all the faculty members, participants, researchers, and students for their enthusiastic participation and active interaction, which makes this program truly meaningful and successful. A keynote of appreciation goes to the organizing committee, coordinator, technical team, and student volunteer for their tireless effort in smoothly conducting this hybrid FDP. This program has truly provided an excellent platform to explore emerging trends, tools, and challenges in intelligent medical system and healthcare research. Once again, I thank everyone who directly and indirectly contributed to the grand success of this program. Thank you, everyone.
One announcement from my side is as a coordinator, I would like to announce that this e-certificate and other appreciation certificate will be provided within 10 days. We are processing that. So this is a valuable information for all the participants that will provide the certificate within 10 days. Okay, thank you. Thank you all. Bye.